Hello, ladies and gentlemen. My name is Carl Hosbrook, and in this video, we will be looking at how the puzzle will solve itself, or more accurately, what do we do with the data we receive from the breadth first search algorithm. First up, I do want to apologize for not uploading this way sooner. At the time of uploading, no one really had any interest in this series. And because no one had any interest, I just kind of forgot about it. And looks like now, for some reason, people do have some interest in this series. So sorry for not uploading sooner. Um, well, let's jump right into it. So in this video, we will be using a coroutine to deal with the data we get back. So if you recall the last video, which I had to rewatch, um, the data we get back is a list of bytes. Now that's the index of the tile we want to move. If you look at this, everything is at its index. So let's say, you know what, let's play. And let's do this. So in order to solve this, we need to move the tile at index 8. Or we need to move tile 7. Now, if I were to go back into here and just again, okay, so all I'm doing now is just to make doubly sure how the data looks that we get back. So from the data we get back, just loop for every one of them and then debug.log them. So if we go back into Unity and play, and if I were to press on 7 and solve, we would get 8. Where's my console? Here it is. And as you can see, we need to move the tile at tile 8. If I were to do this, and then, okay, so first we need to move the tile at tile 6, which is over here, then at 7, then at 8. Bam, we have 1. So that's how the data looks. I'm just going to remove this for now. And now under Game Manager, we are going to do the following. This is IEnumerator solve list of bytes things to solve. Now, the things to solve, the list of bytes, that is the indexes of the tiles we need to move. The reason we're using a coroutine or an IEnumerator is for it to do it on its own without breaking the application. You don't want to um, solve it, and as it's solving it, you can't do anything else in the program. It can also give you a lot of customizability regarding this, which means before you move one tile, you wait a certain amount of seconds. It's pretty cool to work with. So from here, we're going to say float delay 0.1. And the reason for this is you can either wait a single frame before moving the next tile, or you can wait a certain amount of time. Now, I prefer waiting a certain amount of time because it looks cooler. That's about the only reason. So what I'm going to do now is this is going to be a double for loop. Now, the first for loop will be going through things to solve. That would mean that item would be at a single time be a byte, and that's the index we want to move. Now, because of the nature of the game, you can only um, move in a single direction or to another single position. Um, for instance, over here, if you want to move 7, there's only one place it can go. If you want to move it again, there's only a single place it can go. Um, so we don't need a to or a from over here with the solve. That's already done in the backend, already done within reverse search. So within this, we are going to do something nice. We're going to yield return new, wait for seconds, and then we are going to give it our delay. Now, this is going to do two things. Um, for one, it's going to remove our very annoying error. Secondly, each time in this for loop, it's going to wait for 0.1 seconds. If you wanted to return for a frame, you're just going to say null. You can't say new null, just you'll return null. But I prefer this yet again because it looks way cooler. So after this, we need the current position of the item we are looking at. The way we do this is vector free. Okay, so vector free cell position equals to positions, and we're looking at the current item. So what we are doing now is in our game manager, we are looking at this positions. If we want to move 7, we're going to fetch its position here. So what we are doing after this is now we're going to do another for loop or another for each loop. Var, and you can't name this item, so I'm just going to name this tile in cells. Now, all we are doing now is we're going to go through all the tiles. We're going to be seeing, okay, listen, where is the actual tile we want to move? So let's look at the scenario. The 7 is over here. Now, we don't know that we want to move tile 7. We know we want to move whatever is in tile 8. Therefore, we get the position first. From there, we're going to see, okay, listen, each one of these cells, which one of them is at position 8? And then we're going to, okay, listen, you're at number 8. I want you to move. That's basically what this double for loop is going to do. So for tile in cells, then we're going to create an if statement. Okay, if the tile we are looking at, its transformed or position is equal to the cell position we want to be looking at, then we are going to move cell. Now, this is one of the reasons that in cell piece I made this move cell method. It just makes things so much easier because you can just tell the tile, okay, listen, you're gonna need to move. From here, I think we can call it and try to solve it. So over here, I want to do an if statement. So in our breadth search, perform search, if we go back here into perform search, in the end, we will return either a null or we will return the current item 2, which contains the moves it takes to solve it. So I want to see if data is not equal to null. If it is not equal to null, then we can say start coroutine, and I'm going to give it solve, and we're going to solve data. Else, this is a nice little thing. Remember the pop-up system we made? All I did here is I made a new method that invokes the pop-up system. So all I'm going to do is show pop-up. And with this, I'm just going to say could not solve. And this should be working just fine. If I go back into Unity and start it, let's search with, let's solve it with effort. Voila. So this works quite nicely. Now, please do keep in mind that this is a relatively hardware intensive puzzle to solve. So let's say you were to invert this completely. um, something like this. This is going to be incredibly hard to solve for the machine. So this is going to return a null. Um, Otherwise, it's going to take forever. You see, could not solve forever for a machine to solve this. Now, this is mitigated by A star, um, but ultimately, yeah, you won't be able to solve everything unless you have a really powerful machine. So if I were to do this and press solve, it should be able to solve it. Could not solve. Why? Okay, let's try. Still could not solve. Hmm. Well, I could solve it. Why couldn't he? Or the algorithm. It seems to be working just fine. Okay, it would seem that the other game states were just too memory intensive. But for all purposes, this video is complete. If you have any questions or recommendations, please leave it on the comment section. And I will see you all later.